All right, guys, welcome to our first video of Mr. Thompson teaching new material. I'm really excited about this unit, as I've told you guys about over and over again. This is Unit 10, it's our trigonometry unit. As you can see, we've got some triangles on the board. And I think trigonometry is awesome for a lot of reasons. Mostly because, as a lot of you know, I was an engineer for a while, for like 5 years, and you use trigonometry like all the time as an engineer. So if you've thought about a career in engineering, and then this is kind of going to be like the test to see whether or not that's maybe for you. And it doesn't all need to make sense like right at the beginning. I know I always tell you guys that the first time you learn new things is always difficult and it's always a little tricky, but I'm hoping that by the end of this unit, we're all going to feel pretty good about it, and you're going to know, like, all right, I'm pretty good at this. Maybe I can be an engineer, and we'll go from there, okay? So what we're going to be doing today, this is going to be 10A Part 1. I'm probably going to record all these videos today, but I'll release them slowly, kind of as we do them, sort of like it would be in our actual class, okay? So the first thing we see on the notes here is we've got a few questions about this guy, Pythagoras, okay? You can see, like, right there, Pythagoras. And there's actually a video. If you just Google, I'll actually put a link on Canvas for this video that kind of talks about him. I started the video and it was pretty interesting, but it was sort of long, so I didn't actually finish it. But yeah, that kind of goes over some of these questions. I'll talk about a few of them here real quick, and I'll let you guys figure out the last one for yourselves. So Pythagoras was a Greek philosopher and mathematician. So he was the guy that kind of, apparently he had like this group of dudes and they all hung out and like talked about math stuff. You can imagine that maybe I would have been in that group back in the day. But then they're all like, apparently they were crazy. They were like cult people or something. I don't know, it's explained in the video. But anyway, the reason why it's relevant is that he was a Greek mathematician, okay? So the Pythagorean Theorem, really what that is that explains relationships between these kind of triangles, and specifically triangles that have right angles here. Okay, and let's remember going all the way back to like Unit 1 and 2, when we talked about these different triangles, we understood that the three angles inside a triangle need to add up to 180. So if this angle is 90 degrees, then these angles are both going to add up to 90 degrees, okay? So let's say this angle was 90 degrees, this angle was like 30 degrees, then this angle would have to be 60 degrees. So that way you get 90 plus 30 plus 60 to give you 180, okay? So everything with 10A Part 1 that we're talking about today, there's going to be a little square indicating where the 90-degree right angle is, okay? So that's really what the Pythagorean Theorem is all about, is this relationship. So I'll get into that a little more in here in just a second. So this third question here, did Pythagoras create the Pythagorean Theorem? I'm going to say this is kind of a weird question, but really he discovered it. He discovered this relationship and then just stamped his name on it. And it was like, all right, this is my theorem now. And it's funny because that's like the way a lot of things happen, you know? Like America was discovered and they were basically just like, all right, this is ours now. So, you know, those kind of things always happen throughout the history of the world. But yeah, so how did the Pythagoreans, how did they think of the relation between two legs and the hypotenuse? I can close the door real quick, 1 sec. I'm making instructional videos, is that okay?
Yeah. We can go around. So yeah, sorry we did.
Oh no, you're good. Yeah, you're totally good.
Okay. Yeah, no, we're good. By 5. That's when we log
Oh,
out.
perfect.
So,
Okay, sounds
you're
good.
good. We can come
Thank
back.
you. Appreciate it. Yeah, you can close that. Appreciate it. Okay. All right. Sorry for that interruption, guys. That was basically the cleaning people here. All the desks are gone. I showed up today and everything was gone. It was kind of crazy. But yeah, they're vacuuming and they're doing a good deep clean of the school today. So anyway, how did the Pythagoreans think of the relationship between two legs and the hypotenuse of a right triangle? I mean, that's going to be the one that you find out on your own in the video, okay? I'm not entirely sure of that. I'm actually curious because I didn't know that there was like this much detail in it. So I'm going to watch the video as well, and then maybe we'll have a discussion on it if you guys want, if anybody has anything to contribute, and we'll go from there. But really the main thing with the Pythagorean Theorem, so what we're doing here, you guys, is, so we've got an example up there, and I'm going to use pink real quick to just talk about what we've got in this equation here, okay? Because the Pythagorean Theorem is all about identifying what is what. So I want to direct you guys to right here, leg squared plus leg squared is hypotenuse squared. Okay, and so then we can substitute variables for the legs and the hypotenuse. A squared plus b squared equals c squared, okay? So I don't want you to get too caught up in like that exact definition. I want you to really think about what this relationship is here, okay? So the hypotenuse, what we're gonna do with all these examples as we go through, I think we've got like a ton of examples to go through here. So with all of these, the first thing I'm going to do is identify the hypotenuse, okay? And I do that by seeing where the right angle is. And if the right angle is here, then the hypotenuse is directly across from that, okay? So I'm going to start by just labeling this, and I'll just put, oh no, pink is out. Is it? Let's see. Yep, pink marker's done. All right, we'll use blue. And by blue, I mean green. Okay, so I'm going to label this, we'll just say HYP for hypotenuse. Okay, we need to remember that this is our hypotenuse. Okay, and so then the other two legs, the other two sides of the triangle, I just said it, those are going to be the legs of the triangle. Okay, so leg and leg. And the important thing to realize here is that it doesn't matter which one is A and which one is B, going back to that equation. The main thing is to understand that leg squared plus leg squared equals hypotenuse squared, okay? And so the last little trick here with this is we need to acknowledge that the legs, there's no way they can ever be longer than the hypotenuse for a triangle like this, okay? So if we get an answer here and my answer somehow I got like 2 for my answer, then I would know I made a mistake because that would mean that both legs is longer than the hypotenuse. Okay, so one more time, I'm just going to write both of those equations that we started with. We'll do it in black up here. Okay, so both of the equations, I'll leave these at the top of the board throughout the entirety of the lecture. So a squared plus b squared equals c squared. But really, like I just said, it's leg squared plus leg squared equals c squared. Okay, so leg squared plus leg squared equals, and I just said c squared, but that's hypotenuse squared. Okay, so hypotenuse, HYP squared. Okay, so let's jump into this first example. And really, the nice thing about this, the Pythagorean theorem, is that the math is not incredibly complicated. It's pretty consistent with how we get our answer. So for this instance, our answer is the hypotenuse. We need to figure that out. So what I'm going to do here is I'm going to substitute each of these values into this equation. So my first value for the first leg is 3. So right here, I'm going to write 3 squared. And then I've got 4 for my other leg. So again, I'm doing leg squared plus leg squared. So 3 squared plus 4 squared. And we're saying that that equals c squared, okay? So equals c to the second power. Okay, so now we have everything we need in an equation, and now we just need to figure out how to get c squared by itself. Well, really how to get c by itself. We've got c squared on the right, so that's good. We always want to get the variable isolated before we're doing anything else to it. Okay, so the variable is like close to being isolated here. We have the second power. We're going to deal with that in a second. But there's a few different ways you can go about this, okay? And the way that I recommend is always evaluate your exponent first. So in my calculator, real quick, what I'm going to do, and I'll just show you guys how I'm doing that right here. So I see 3 squared plus 4 squared, so I'm just going to do that. I can do it separately as 3 squared. So 3 squared equals 9. Okay, so I can write 9 plus, and then 4 squared. So I do the same thing. I enter 4 squared into my calculator, and that gives me 16. Okay, 9 plus 16 equals c squared. So if I wanted to get real crazy, or if I was just feeling pretty confident with it, really what you can do is you can put that all in at once. You can go 3 squared, so 3 squared plus 4 squared, and that gives me 25. And if you just do 9 plus 16 in your calculator, you're going to get 25, so you're good either way, okay? So 25 equals c squared. Okay, now some of you have probably already figured out what the last step is we're going to need to do to solve this. And whenever I have a variable to the second power, what's the inverse of the second power, Carlos? Carlos would for sure know. He would be like, well, you're going to use a square root. Or a lot of you guys are like, it's that little squiggly thing. Yes, we're coming back to that. Okay, so we're going to do that to both sides of the equation, and that's how we get the variable c by itself. So square root of there and square root of there. If I evaluate that in my calculator, the square root of 25 is going to be 5. So I'll show you guys that once here. And then for the rest of the examples, we're going to just be doing it. I'll just kind of tell you what the answer is, and you can check on your own, okay? So I go second here. That pulls up my square root, 25. I press enter, and I get 5. Okay, so on the left here, I've got 5. And on the right here, these cancel. Remember, the second power, that cancels out with the square root, so I just end up with c by itself. And that's my answer. And this makes sense now, because I can think about it, and if this is c is equal to 5, Well, that's bigger than both of these numbers, so like it works out. It meets that criteria that we established at the beginning, that the hypotenuse is always going to be longer than either of the legs, or both of the legs. Not both of the legs like added together, but both of the legs separate, okay? All right, so that was the first example. Now we're going to move on to the second example. Okay, so what we just did was this one here, and what we're going to do next is going to be this one. Okay, so again, the first thing I want to do is establish what the hypotenuse and what the legs are. Okay, so the hypotenuse is, we have the right angle here, so it's going to be just directly across from the right angle. Okay, so hypotenuse, HYP, which means that this is a leg and this is a leg. So 24, this is one of our legs. And X, I've just labeled this, is it actually labeled? Yeah, it's labeled as X there. I think I'm gonna regularly be referring to the missing side length as X, so just be prepared for that. So this is our other leg. Okay, so now we're just gonna go back to this main equation, the leg squared plus leg squared equals hypotenuse squared. Let me just double check and see that you guys can see the colors pretty well. Yeah, they're showing up okay. So what I'll do here is I'll color code what I'm doing here just so you can kind of see how this problem is gonna be different from this problem. Okay, so over here, our hypotenuse was in green everywhere, and that was just here, right? And then our legs were blue, or I'm sorry, our legs were red. I don't know why I keep saying blue. Maybe because I'm missing my blue marker. Okay, so here I'll actually write it with the colors. So, to write it the similar way we did that, we're gonna start with 24. So I'm gonna go 24 squared. And all that is that's my first leg. Leg squared, 24 is a leg, 24 squared. And then we'll go plus, this is our missing side length. It's still gonna be X. We don't have a number yet, so we're gonna go X squared. And then I'm gonna write equals my hypotenuse, which we actually have a label for now. We have a number for the hypotenuse, so that's 26 squared. Okay, so now I want the variable by itself. How am I gonna do that? Person who just walked in late. I'm gonna do that by just kind of moving some things around. So I want X squared by itself, and we have 24 squared plus X squared. So the trick here is we can kind of leave it. If you want to evaluate the exponent immediately right now, you can totally do that if you want, okay? But the way that I was kind of doing it, I'll do it both ways as we get on with more of these examples, but for this one, I'm gonna subtract both sides by 24 squared, okay? And I'm not even gonna evaluate the exponent until I get everything on the same side. So minus 24 squared, and then over here I'll do minus 24 squared, okay? So it goes away on the left, and now we have this on the right. So now we've kind of set it up very similar to how this was set up from the beginning. We have both the exponents, and in this case, the reason that they're subtracted is because we're finding a leg length, okay? So we're doing hypotenuse squared minus the leg length that we have squared, okay? And that's gonna give us the remaining leg length. And we're gonna do it very similar. We just need to remember that this is a subtraction sign. If you do addition, then you're gonna get a big number here that's gonna be bigger than the hypotenuse, and you'll know you made a mistake, okay? So now, what we have is X squared. We've got 26 squared, and so equals 26 squared minus 24 squared. So now again, you can evaluate each of these separately in your calculator, or you can do it all kind of in one line. Okay, so I'm gonna go 26 squared. You can see my reflection in the calculator. That's kind of funny. And then again, I just made that mistake. I did plus, but really we should be doing minus 24 squared, and that's gonna give us 100. Awesome. I like that number. Okay. So we do these, we just did this in the calculator, and we saw that this was equal to 100. And again, if you did 26 squared first and you would get some big number, I think I actually have the numbers here. So if I did 26 squared, that's 676. 24 squared is 576. So 676 minus 576, that's how we get 100. And this isn't our answer yet. This is our X squared, okay? This is our X squared. So again, one more time, Chris, who's on his phone, I'm just going for the third period kids today, you guys. Chris would be like, all right, well, Carlos figured it out, so I can figure it out too. X squared equals 100. To get X by itself, I do the square root of both sides, okay? So I do the square root of the left, that cancels with the second power. Square root of the right is gonna be, the square root of 100 is 10, if you do that in your calculator. So my answer here ends up being x equals 10. Okay, so I hope that this is kind of starting to make sense, really what we're doing here. And the trick is just in getting the variable by itself, honestly. That's the big trick with all this. Okay, so we're going to do one more here, and then that's where I would say maybe you guys pause your video and take a break, but I'm going to keep going. We're going to keep chugging through. Okay, so we've got those two examples, and yeah, you can pretty well see what we've got going over here. Okay, so again, we'll go with colors one more time. And we're going to start by identifying our hypotenuse, HYP. And the way I did that is I saw this is the right angle. I've got that little square here. That means this is the right angle. I go directly across from that, that's my hypotenuse, okay? So if that's the hypotenuse, that means this is a leg and this is a leg. Okay, so now I can just write this out the same way. And the way that I know, so if I was to compare this to one of these two, the way that I would know that I'm comparing it to that first one is because our missing variable is the hypotenuse, the same way it was in the first example. So I'm going to set the problem up literally the exact same way, okay? So I'm going to go, my first leg, that's going to be 4 squared, plus my second leg is 6 squared. And I should actually rephrase that and say the leg length is 4, okay? The leg length is 4, the leg length is 6. But when I'm writing them into the Pythagorean theorem, we're doing leg squared plus leg squared. So that's how I'm getting 4 squared plus 6 squared. This is going to equal c squared. Okay, and again, for those of you who are wondering where this is, I just got onto the second page here, okay? So I'm onto the second page. We're doing this example in the upper left of the second page. Okay. So we set it up perfectly, 4 squared plus 6 squared. And again, now we can evaluate these separately. So we'll do it separately at this point because we did them together for the last example. So we'll do them separately. 4 to the second power, I do that in my calculator, I get 16. 6 to the second power, I do that in my calculator, I get 36. Equals, and c squared is still in green. Boom, boom. Okay, so then if I do in my calculator 16 plus 36, I believe that gives me 52, and it does, so 52. So this is a little bit tricky. Let's go back to red. Actually, you know what, we did the math already, so we can just put it in black. Okay, so 52 equals c squared. All right, so now again, the last step, as you guys should start, I hope you're starting to see the pattern here, that once we've got the variable squared, the very last step is going to be take the square root of both sides, okay? Jose, is that right? Jose would probably be like, thank you, Mr. Thompson, because Jose is just always so thankful. I appreciate that, Jose. Okay, so I do this to the right side, and the second power cancels out with the square root, and I'm left with just c. And then on the left side, 52 is not a perfect square, and that's okay. We can still evaluate the square root of it. I'm going to show you guys real quick what happens when I do that. So I get to my square root function in my calculator, I go to 52, and again, I don't need this closed parentheses, but I'll put it that at this point. And I get 7.21, and that's totally fine. Like, that's close enough to being a right answer. And this makes sense because if it was the square root of 49, it would be exactly 7. So because this is a little higher, it makes sense that our answer would be about 7.2, just a little bit above 7. Okay, so the square root of 52 is going to be about 7.2. And this is not an exact answer, it's an approximate answer. So I put that little squiggly. I don't really need to, but I'm just kind of OCD about it, so I do it a lot. But yeah, so this is our answer. And again, if we go back and we just kind of give this a common sense check, what I'm looking for here is to make sure that my answer here is bigger than both of these numbers, and it is. So that makes sense to be the answer we are looking for. Okay, and we can kind of do that check with all these. We didn't do it with the second problem, but now we can go through and just look at it real quick and see, okay, 26 should be the biggest number. It's bigger than 24, and the answer we got is 10, so that totally makes sense for that to be the right answer, okay? All right, so we're gonna power through the last few examples. Let's see, how far in the video are we? We are 20 minutes in, that's not bad. We're gonna go through all the examples, you guys. 1, 2, 3, 4, 5, we got 6 more to do. Take a few minutes per example, and it'll be pretty good. It'll be basically the length of like a class period, okay? All right. Also, if anybody has any like editing tips, or if you're watching these videos and you got any advice for me to just make better videos, I'm totally open to suggestions, because at the end of the day, this is for you guys. This is for you guys to learn, so if there's something that I'm doing, or if there's like a different way, really anything I could do to make this a better experience for you guys, let me know, and I will do my best. If you want me to edit the videos or anything like that, I would be more than happy to, okay? All right, so this is going to be, so we just did the third example, and we're gonna move on to this example up here. This is gonna be our fourth example, okay? So I guess I'll start labeling these. So this is example 4. And we have triangle, and this one's a little tricky, and it's tricky because if you're not paying really close attention, it's hard to see where the hypotenuse is. We've got an x here, we've got a 14 here, and we've got a 20 here. So the first indicator of a hypotenuse would be that the number's pretty big, okay? That could be an indicator. I guess it shouldn't be the first one. The real first indicator is that the hypotenuse is across from the right angle. So we've got the right angle at the top. This triangle is configured a little funny, but we can still figure it out, okay? So our hypotenuse is 20. So I'll label that. We'll go back to, we'll just label the, on the triangle with our colors, and then I'll go through the problem in all black. I think that should be okay for now. So this is a leg, this is a leg, and this is our hypotenuse. And don't get caught up on what that means. That's just kind of probably the Greek way that they came up with. It's sort of funny because hypotenuse and then a leg and a leg. Like, why not call the hypotenuse, like, I don't know, a torso or something? Maybe that wouldn't make any sense. I'm just rambling, you guys. Okay, so we're going to set it up using the equation that we started with up here. Leg squared plus leg squared equals hypotenuse squared. So I'm going to say this is my first leg, so x squared. Again, this is what we're solving for, okay? Plus 14, that's going to be my second leg, so 14 squared equals, the hypotenuse is 20, so that'll be 20 squared. Okay, so this is just, we're going back to our basics of algebra. Now that we've figured it out like this, we almost don't even need to think about the triangle anymore. I just know that I need x by itself. So the first thing I do is subtract both sides by 14 squared. So minus 14 squared. And you know what, actually, let's do this one a little different. Let's actually evaluate what 14 squared is and what 20 squared is, just to show you guys it's going to work out the same way. Okay, so if I do 14 to the second power, I'm going to get 196. So I'll just rewrite this as another line. So x squared stays the same, plus 196, I just evaluated 14 to the second power is 196, equals, now let's do 20 to the second power. Okay, so 20 squared, 20 to the second power, that gives me 400. Okay, so equals 400. Okay, so now really what I'm doing when I do 20 squared minus 14 squared, to get x squared by itself, is I'm going to be doing 400 squared minus 196 squared. Okay, this is equal to this is equal to this. So I'm going to do minus 196 on both sides. And when I do 400 minus 196 in my calculator, I get 204. Okay, so it went away, 196 went away on the left, and I'm left with just x squared here on the left. The right side, I simplified 400 minus 196 to get 204. Okay, so now the last step again, one more time. I'm picking on third period today, so Michael would probably immediately, he would have known the answer like when I wrote the question down probably. Michael would have been like, the answer is, you take the square root of both sides. Okay, so we square root both sides. Square root cancels with the second power on the left. So on the left, I'm left with just x equals, and then when I do the square root of 204, I get about 14.3. So I'll show you guys that in the calculator. Square root, so I get to my square root, and I go 204, and I press enter. About 14.28, so I'm gonna round that up to 14.3. And again, I'll give it a little squiggly, saying that this is not exactly equal, but it's approximately equal. And a little trick, if I wanted to make it exactly equal, what I could do is I could just leave it as the square root of 204 as the answer. But I always like simplifying these with the Pythagorean theorem, mainly because it's a good way to visualize and think about the actual lengths, okay? So I give this as my answer, And if I think about putting that here as 14.3, an interesting thing to note is that it's almost exactly the same as the other leg. And that's fine, it's just kind of an interesting thing. And they're both smaller than the hypotenuse. The hypotenuse is 20, our leg we just solved for is 14.3, our other leg is 14. So when I'm looking at this, I'm like, all right, that makes sense. This triangle makes sense. I didn't get some big crazy answer for this leg that was bigger than that, so we're in good shape, okay? Awesome. All right, we've got two more of these triangle examples, and then we've got some story problems. So I'm gonna put this one up on the board. We'll call this one example 5. Okay, so we'll say this is example 5. And I've got a triangle that's kind of flipped a little bit. My right angle is here, and I've got P. This is a variable P. We've got 12, and we've got 15, okay? So again, we're looking at, first thing we're gonna do is label leg, hypotenuse. Okay, awesome. So I've got my legs, I've got my hypotenuse, so leg, hypotenuse, we're good. So my first leg is P, so P squared, plus second leg is 12 squared, equals my hypotenuse squared, so 15 to the second power. And again, remember guys, when I'm saying squared means the same thing as to the second power, okay? And that's the only exponent we're gonna be using for this stuff today. Okay, so what do I gotta do to get P squared by itself? Jaylee would for sure know the answer. If I was like Jaylee, she'd be like, oh, I was like doing a million things in my head all at once because I'm freaking brilliant, but this is what we're gonna do. We're gonna do minus 12 squared on both sides. Okay, so it goes to 0 on the left, and I still have P squared here, and I'm gonna have 15 squared minus 12 squared. Okay, I don't remember 15 squared off the top of my head. 15 squared, 225 minus 12 squared is 144. Okay, so I do 225 minus 144, and I get 81. And for some of you, maybe a light immediately goes off in your head. The 81's a perfect square, so this is gonna work out all right. Okay, so all we did, well, we'll just recap this whole, what we did at the start. We labeled our legs and our hypotenuse. We had our legs here, our hypotenuse here. It's 15 squared, okay? So I subtracted 12 squared on both sides. That's what got me to here, P squared, our missing leg length, equals the hypotenuse squared minus the second leg length squared. Okay, I evaluated the exponents there. 15 squared is 225, 12 squared is 144. 225 minus 144 is how I get 81, all right? So now the last step here is I'm gonna do square root of both sides. Square root of both sides, cancels out, and I'm left with just P on the left. The square root of 81 is 9. So P equals 9. So, and now again, if I think about plugging that in here, let's just erase, so let's just put 9. Then it makes sense with what we were talking about earlier with the hypotenuse and the leg lengths, okay? So I see the hypotenuse is 15, that's the biggest number, so that works. These are both smaller, it totally makes sense, we're good. That's gonna be the right answer, okay? They're here like vacuuming the floors, and so people are making all kinds of noise, as you heard earlier in the video when I had to go talk to them about it. So I feel like I might get kicked out here. We'll definitely finish this video first. And again, you guys, this is really the last video you guys need to watch before spring break, which is next week. So if you saw my Monday update video from earlier today, you would see that. Okay, so this will be example 6. Example 6, and we are here with this one. That's what we're looking at here. We're about a half hour in, that's pretty good. We only have a few more examples left, so this video should hopefully be under probably about 45 minutes would be my guess. Okay, so first thing we're doing, what's the first thing we're doing? Mike Kinsey, who just walked in and gave me a ton of attitude. Just kidding, Mike Kinsey, but I'm sure that's what would have happened. What we're gonna do here is we got to identify our hypotenuse, okay? And I forgot, did I forget, or was it on the notes? It was on the notes, I just forgot. Right angle right there. Okay, so I go across from my right angle, that's my hypotenuse. If that's my hypotenuse, that means that this is a leg, and this is a leg. Okay, so now let's fill out our equation. Leg squared plus leg squared equals hypotenuse squared. So 8 squared plus y squared equals 12 squared. Okay, so leg 8 to the second power, leg y to the second power equals hypotenuse, which is 12 to the second power. Okay, so notice that the variables are different here. Here I had p squared labeled first in this example. In this example, I've got 8 squared labeled first. It really doesn't matter because at the end of the day, we're trying to isolate y by itself. So the first step here is I'm going to go minus 8 squared on both sides. Okay, so minus 8 squared. And I'm going to end up with just y squared on the left equals 12 squared minus 8 squared. Okay, so 12 squared is 144. 8 squared is 64. Okay, so I'm going to do 144 minus 64, and that's going to give me 80. Let's double check. 144 minus 64 will give us, yeah, that works. Okay, so y squared equals 80. And again, we've got to this point. Now our last step is square root of both sides. That way that cancels out. We're left with just y equals, and again, when the square root of 81 is a perfect square that gives us 9, well, that means the square root of 80 is going to be just a little under 9. And so if I do that in my calculator, I evaluate the square root of, square root of 80, and I get 8.94, okay? So we can estimate that that's about 8.9. And that makes sense, okay? So if I put that in here as 8.9, the hypotenuse is still the longest leg. These are both shorter. This one's a little longer than that one. That's okay, and we're in good shape, okay? So now we've got some story problems, you guys. Story problems, and this is where in trigonometry and with things like this, going back to what I said about like engineering and trigonometry having to do a lot with it, this is where it's really relevant, because like there'd be days when I was working as an engineer where I'd really have to think about this stuff and think about the relationships and what kind of right triangles are made and structural things, and it was always challenging, but it was really fun. And I think trigonometry is just really cool. It's because it's more about, it's like spatial math. It's not necessarily like this abstract stuff we've been talking about all year where some of it's relevant, some of it's not. This is like all relevant in real life, as you will see with these story problems. Okay, so the first story problem we're doing, this was 3, 4, 5, 6. This will be example 7, our first story problem example. Okay, so a 35-foot ladder is leaning against the side of a building and is positioned such that the base of the ladder is 21 feet from the base of the building. How far above the ground is the point where the ladder touches the building? Some of you may have seen my work right there, and that's totally okay, but the trick to this kind of problem, again, this was example 7, story problem number 1. Okay, so really the trick to these is identifying what should be where, okay? And this one's a little tricky. The first thing we know is that there's a ladder that's 35 feet long and it's leaning. So that should be an indicator that it's kind of at an angle. So the base of the ladder is 21 feet from the base of the building. So let's imagine we've got a building like this. Okay, there's like windows. Everybody's social distancing, so maybe someone is like watering their plants right here. There's like a little flower or something. And there's a dude who's just chilling. And that's not proportional at all, but you know, you get what I'm saying. So this is our building, and the building, we don't know how tall the whole building is, but we know that the ladder is 21 feet from the base of the building, okay? So if I were to kind of just draw a dotted line here and label this as 21 feet. And I know that the ladder, so the base of the ladder is right here, and it's leaning up against the building, kind of up here. So voila, we have all the numbers that we need, and now this looks like a triangle, okay? So the first thing we were given is that the ladder is 35 feet long, so a 35-foot ladder. Okay, so we have a dimension here that's 21, a dimension that's 35, and what the question is asking for is how far above the ground is the point where the ladder is touching the building. So right here, basically, okay? So we care about this length. Again, this isn't necessarily the whole height of the building, this is just where the ladder touches the building up here. So we'll call this x. This is going to be our missing variable x. Okay, so the tricky thing here is we weren't like given where the right angle goes, but we can kind of visualize it here. The right angle's not here, it's not here, it's going to be at the base of the building. If you were walking along the base of a building, you could see, like even right here, I can see that the angle between, you guys can't really see this on the camera, but the angle made by the wall and the floor is like a perfect 90-degree angle. So that kind of makes sense to visualize that way. So now let's set this up. Let's get our legs and our hypotenuse labeled. So we've got hypotenuse here because it's across from the 90-degree angle. And then I've got a leg and a leg. Okay, perfect. So now I can fill this out with the numbers in the Pythagorean theorem. So my first leg is x squared. My first leg is x. In the theorem, it's x squared plus 21 is my second leg squared equals, my hypotenuse is 35, so we'll put 35 squared on this side. Okay, we'll change up the order again just to show you guys you can do it a ton of different ways. And when I say change up the order, what we'll do first here is we'll evaluate what these actually are when we put them in as exponents. So 21 squared, 21 to the second power is 441. 35 to the second power is 1,225. And then x to the second power stays x to the second power. Okay, so if you like doing it in this order, then go ahead and do it like this on all your problems. That's totally okay. All right, so now all I've got to do is I need to get x squared by itself, okay? So third period, who's someone else in third period? Matsy is probably sitting in the back on her phone or something. Matsy, what do I got to do to get x squared by itself? Subtract 441 on both sides. Nice, Matsy, way to go. Minus 441, minus 441, okay? So now on the left, I have just x squared by itself equals, and then in my calculator, I'm going to do 1,225 minus 441. And that gives me 784. Okay, so now my last step, Julia, what do you think my last step is going to be? Take the square root of both sides. Oh, way to go, Julia. Take the square root of both sides. Okay? So that way these things cancel out. I get x equals the square root of 784. I'll do that in my calculator, square root of 784, just like this. Press enter, and I get 28, a perfect 28. That's kind of nice. Okay? So 28 feet is really our answer. And now let's think about it back in the scope of what the actual problem was. 28 feet up, that's right here. And that kind of makes sense. Again, the hypotenuse is the longest one, which is what we're looking for. These are both lower, but really, yes, you can kind of visualize if you were like walking down the street and you saw this, you could be like, oh, that ladder's 21 feet across and 28 feet up. The ladder's 35 feet long. Like, it all works out. It makes sense, okay? So there's example 7 for you. We will go now, we'll flip over to the very back page here. Okay, so the very back page, we've got 2 more story problems. Okay, and this 7th one, or I guess this is example 8, second story problem. We'll do this here. This is probably the most confusing to visualize, and I'll explain why after we write everything down here. So what I'm reading here is a carpet measures 7 feet long and has a diagonal measurement of square root of 74, which is kind of weird, but we'll get to it, okay? So I'm thinking of a whole carpet, almost more like a rug. Like if you just had a rug on your ground in your living room or whatever, and it's 7 feet long. So and it doesn't matter which dimension we pick first. I'm going to say this is 7 feet. And then the diagonal measurement, okay, so this measurement, diagonal, is the square root of 74 feet. Okay, so if we wanted to evaluate the square root of 74, we can totally do that. 74 squared, or whoops, actually, second square root of 74 is about 8.6, okay? So I'll just write that up here. The square root of 74 is about equal to 8.6, okay? And we're asked to find how wide the carpet is, so we need to find this measurement. This is going to be x, okay? So now, the trick here is going to be to figure out where the right angle is. Well, this carpet is a perfect rectangle, right? If it's a perfect rectangle, then obviously this is not your right angle and this is not your right angle. Your right angle is here. It's at the corner, okay? And the reason that it's not either of these two is because we're kind of like, really what we're doing here when we look at this problem is we're sort of visualizing like this. Okay, we took away those dimensions because really that long dimension here is going to be, or I should say that short dimension here is the same as x. The long dimension up top is the same as 7. Okay, so we just want to visualize this as a triangle to get this last dimension here. Okay, so let's start plugging in. Actually, we'll define what we've got where first. So our hypotenuse is, of course, right here, which means that we have a leg and a leg. Okay, so now let's just fill out what we know. So leg squared plus leg squared, I'm going to get 7 squared plus x squared equals the square root of 74 squared. Okay, so I'll even use parentheses here, 74 squared. So this is kind of interesting because what happens here when we do the square root of 74 and we take that to the second power, just the same way as when we take the square root of a variable like this that's to the second power, it just kind of, the square root cancels with the second power. Okay, so really what this is going to be is 74. Okay, so I've got 7 squared plus x squared equals 74. Okay, so now I can evaluate this as well. 7 squared is actually going to be 49. Okay, now I want x by itself, x squared by itself, so I do minus 49 on both sides. And I'm going to end up here with x squared equals 74 minus 49, I believe is 5. 5, that's not correct, you guys, it's 25. I got a little ahead of myself. 74 minus 49 is 25. Okay, so now our last step is square root of both sides. Square root of both sides, and I get x equals the square root of 25, which is 5. That's where that came from, okay? So this dimension right here is 5 feet. So we know that this carpet is 7 feet wide by 5 feet long. And this is a good example to kind of go back and just double check your work, okay? And when I double check my work, what I want to do is I want to make sure that when I do 7 squared plus 5 squared, I get this as my hypotenuse, okay? So I go 7 squared plus 5 squared. I do this in my calculator like that, okay? And I get 74, okay? So I get 74 for leg squared plus leg squared. And really I know that that is going to be the square root of 74 squared, which we already know this is 74. It's like we did it right. Kind of back checking this way. I know that was a little sloppy, but that's our way of double checking that we did it right, okay? All right, we just have one more example, you guys, and then we are done with today's video. I wanted to stay longer and do like all the videos, at least for this whole unit, because my roommate is getting all nervous because I like come to school even though I don't touch anything except for what's in here and I don't talk to really hardly anybody. He's like, you should just go and do all your videos at once. I'm like, maybe I will do that. But we'll see. Okay, so our very last example is right here. This one's tricky. The main mast of a fishing boat is supported by a sturdy rope that extends from the top of the mast to the deck. If the mast is 20 feet tall and the rope attached to the deck 15 feet away from the base of the mast, how long is the rope? Okay, so let's imagine a boat. That's what we're talking about here. We've got a boat like this. And this boat has a pole. Maybe it's a sailboat, so it's got a pole kind of like this, and that's what like the mast is. At least that's how I visualize it. If someone out there is like a boat expert like Isaac, that's definitely something Isaac would be like, actually, here's all the things that go into boats. And I'd be like, Isaac, you're too smart for me. I don't know what to tell you. But anyway, here's our mast, and that's 20 feet tall. Okay, that's given in the question. Okay, so this is 20 feet. The rope attached to the deck 15 feet away from the base of the mast, okay? So I know that there's gonna be some dimension here. This is gonna be about 15 feet. And we wanna know how long the rope is. Well, the rope is connected from the top of the mast down to here. So this is our missing variable x, okay? So the first thing we're gonna do is identify where's the right angle. Well, the right angle happens kind of when you get that exact perfect square looking thing right there, okay? So our right angle is gonna be here. It can be like all the way, it doesn't really necessarily matter, okay? So because our right angle is right here, that means that this is our hypotenuse. Okay, so I'll go back here and we'll label this HYP. If that's the hypotenuse, that means that this is a leg and this is a leg. Okay, so now we have everything we need to solve for the length of the rope, which is the hypotenuse. Okay, so I can do leg squared, 15 squared, plus leg squared, 20 squared. Okay, so 15, that was our leg, 20, that's our other leg, and that's going to equal our hypotenuse, which I've just decided on a variable x, to the second power. Okay, so this is how we're going to solve it. And again, we can just evaluate this all at once on our calculator if we want to, and I'm going to do it that way, just to show you guys that, again, you can do it a lot of different ways as long as your math principles are sound. So 15 squared plus 20 squared gives me 625 equals x to the second power. Okay, now to get x by itself, one last time. Johan, what are we going to do? Johan probably showed up today with like a bell cow or something. Johan's always showing up with random things. Johan's like, Mr. Thompson, take the square root of both sides. I'm like, nice, Johan. Square root of this, square root of this. Okay, so 625. Square root of 625 is going to give me 25. The square root of x squared just means the second power and the square root cancel, so I'm left with x. X is 25. And now when I go back and I think of this in the scope of the problem, I've got, this is now 25 feet. And what is it that we're always looking for with these ratios, you guys? What we're looking for with the ratios is making sure that the hypotenuse is the longest leg, okay? Or I shouldn't even call it a leg. The hypotenuse is the longest triangle side, okay? So 25 is bigger than 15 and 20. This makes sense. It works out, okay? So that is it for the notes on this section. 10A part 1, this is all your Pythagorean theorem stuff. If you have any questions, if any part of this lecture was confusing or didn't make sense, like seriously, either send me an email, type a comment in the YouTube video, send me anything on Canvas. Like I really want to help you guys explain, right? I want to help you guys understand. I want to do my best to explain things here. Okay, so what we're going to be responsible for is the homework. And so this homework's not going to be due for a while, but we've got our homework, Unit 11. And for what we just learned today, there are, looks like we've got 2 pages of homework, okay? So we've got 6 problems here, and again, these are all, we've got like, you've got your right angles called out, you've got dimensions, you've got something that's missing, so you can just label the missing dimensions with a variable and do them just how we did here in class. And then you've got, it looks like another 6 more. So this really shouldn't be too bad, mainly because these are not super difficult questions, okay? Some of these are spiral questions where we're going back to stuff we already learned, but really we only have like a total of 10 new questions worth of homework. Okay, so I'm gonna get all this homework packet should be up on Canvas by the end of the night tonight. Today is the 30th, okay? So we got through that lecture. It took us about 50 minutes. That's not bad, you guys. That's about how long it takes when we're actually in class. And I give you guys homework time, and half y'all just play on your phones and don't even do your homework. But you know, it is what it is, okay? So let's make sure we're staying on task. I hope everybody is safe. I hope everybody is taking care of themselves, and I'll see you guys in the next video.